Good morning. In our last class, we have started our new chapter, light. And there we have seen some new laws, okay, some important laws and some properties. We have started learning some properties of light. Okay, so today we will resume learning what are the peculiarities of images formed again. Okay, so I will just share my screen. See, in this chapter, we have seen how we are able to see things through our eyes, but still how? Then we have seen laws of reflection. Actually, how many uh, laws of reflection we have learned so far? Yes, we have learned two laws of reflection till now, but there are more. And then we have seen incident ray, and about the ray which comes back from the surface, we call it reflected ray. And some a normal is also we have defined it. Now, then we have seen the angle of incidence and angle of reflection. This is combining these two definitions. We have seen the first, or not just first, a law of refraction. Angle of incidence is always equal to angle of reflection. Okay, then we have moved and we have seen that the incident ray, the normal at the point of the incidence, and the reflected ray all should lie in the same plane. This was the another law of reflection. Okay, so and then we have seen image formation in a plane mirror, and finally we have seen lateral inversion. Okay, so I hope that all of you have read the textbook clearly, and if no one has asked me any doubt, it means I suppose there is no doubt at all. Still, if you have any doubt, you can ask me. Okay, so let us move to our next section. 16.3, regular and diffused reflection. We are going to learn what do you mean by regular reflection, or what do you mean by diffuse reflection. For understanding this, first of all, imagine that the parallel rays are incident on an irregular surface as shown in figure 16.6. See, like this. Okay, parallel rays. See, all the rays which are incident on this surface are parallel, as you can see. But a difference is that the surface upon which it is being incident is not regular. That is, they are irregular. Okay, means they are not smooth. It has going like this, all such kind of way. Okay, now our question is, and one more thing, remember that the laws of reflection are valid at each point of surface. Now, using these laws of reflection, if we are constructing a reflected ray, the question is, are they parallel? The reflected ray, are the reflected rays parallel to each other? We can see when we construct that they are not at all parallel. Okay, see, look at the figure. See, if we are considering this ray, which is incident, and its reflection will be here like this. But for the next parallel incident ray, the reflected ray will be like this. From this itself, we can see that they are not at all parallel. Okay, when all the parallel rays reflected from a rough or irregular surface are not parallel, the reflection is known as diffused or irregular reflection. So I think this definition is clear to you. Means we can see that many rays are incident on a irregular or rough surface. Many parallel rays, not just any rays, many parallel rays. That's the question. Then the reflected ray, okay, is not parallel. then we can say that this type of reflection is known as diffused or irregular reflection. Okay, so this is a definition. It can be asked in the question as well. I mean exam. What do you mean by diffused reflection, or what do you mean by irregular reflection? Okay, now remember that the diffused reflection is not due to the failure of the laws of reflection. It is not actually, you may be thinking, how can we say that this is a law if it is failure in this case? No, that the answer to this question is that the loss of reflection is not a failure, because this diffused or irregular reflection is caused by the irregularities in the reflecting surface, like that of a cardboard. Okay, that is the problem. It is not because of the problem of loss. Okay, but on the other hand, reflection from a smooth surface like that of a mirror is called a regular reflection. See, you just need to understand only one definition, because actually from that definition itself you can generate the next one. Okay, see, if you know about what do you mean by regular reflection, from that knowing itself you can learn that reflection from a smooth surface like that of a mirror is called regular reflection, and images are formed by regular reflection. See, you can see here as regular reflection. This is, first of all, the rays are parallel. Two things we are seeing. First thing, what is the first thing? Incident rays are parallel. Okay, next, now there is one more thing, second thing. Okay, you can see that the surface of reflection, it is smooth. Okay, it is regular, means it is forming a straight way. There is no sharp edges, nothing like that. Okay, as a result, the reflected ray, it is also parallel to each other, and we are calling this type of reflection as regular reflection. So I think this is clear to you. Now next, do we see all the objects due to reflected light? Okay, we have seen in the earlier sections that we are seeing objects either by the reflected their own light or by reflected light. That was the question. That was we have learned. But here we are asked a question: are we seeing all the objects due to the reflected light only? Let us see. Nearly everything we see around us is seen due to reflected light. For example, consider moon. Moon receives light from the sun and it reflects it. Okay, that's how we are seeing the moon, because we know that moon itself can't produce light. Now, the objects which shine in the light of other objects are called illuminated objects. Okay, the objects which shine in the light of other objects are called illuminated objects. See, you can say an example of illuminated objects, which is moon. Many illuminated objects, other illuminated objects are there. Okay, next, there are other objects also which give their own light, such as sun, fire, flame of a candle, and electric lamp. Their light falls on our eyes. That is how we see them. The objects which emit their own light are known as luminous objects. Okay, so there is Paheli, or this boy has another doubt. Can the reflected rays be further reflected if incident on another mirror? Do you understand his doubt or his question? His question was, suppose this is a reflecting surface and then a ray is incident on it. Okay, we should draw an arrow mark. Then the ray has reflected. So let it go like this. Okay, it is going like this. His question is, can this reflected ray again be incident on another reflecting surface or another mirror? That was his question. Like if I extend this here, okay, is this possible? That is his question. Is this possible? This is the non-smooth surface. Okay, so let us see if a reflected ray can be further be reflected on another mirror. Section 16.4, reflected light can be reflected again. Okay, let us see how we are doing so. Can you actually there are many incidents you may be knowing coming to your mind. One, for instance, let us discuss one incident. When you have gone to visit a hairdresser, of course we are sitting in front of a mirror, and after the haircut is complete, like this, he or she holds a mirror behind you how your hair has been cut. See, like this. Actually, this is actually what is this? The image or the ray from the backside of our head is being incident on the mirror, which is on the hands of this hairdresser. Okay, on this mirror, and then this image is again incident on this mirror. Okay, and thus we are seeing the backside of our head, right? So we can obviously say that the reflected ray can again be incident on another mirror. Okay, see, Pahle recalls the construction of periscope. Okay, in the periscope also we are doing the same thing actually, right? Because the image from one ray is reflected on the other another mirror, and thus we are seeing that image. Okay, the periscope makes use of two plane mirrors. Okay, now you can see where these periscopes are used. Periscopes are used in submarines, tanks, and also by soldiers in bunkers to see things outside. See, maybe for 1 mark, you could be asked what are the uses of periscope, or periscope is used where in which all instances. Okay, so we can conclude that reflected light can be reflected again. Now, the next section, 16.5, multiple images. Okay, what do you mean by multiple images? You are aware that a plane mirror forms only a single image of an object. What happens if two mirrors are in combination? Let us see what happens. Okay, for that knowing, we are conducting an activity. Fine. Take two plane mirrors. Okay, then like this. Set them at right angles to each other with their edges touching. To hinge them, you can use adhesive tape. Place a coin in between the mirrors. How many images of the coin do you see? By looking at this, we can see 4 images of the coin. Okay. Now hinge the mirrors using the adhesive tapes at different angles, say 45 degree, 60 degree, 120 degree, 180 degree. Okay. In each of these cases, we will receive a different number of images of the coin or not. Let us check. Now, place some object, let it be a candle, in between them. Note down the number of images of the object in each case. Now, finally, set the two mirrors parallel to each other. Parallel to each other. Then, look, find out how many images of a candle placed between them are formed. See, if these are the mirrors, see, these are the mirrors, a candle is placed in between them. Then look at the image in the plane mirror. How many images are formed? Let us check. Okay. Now, can you explain how you can see the back of your head at the hairdresser's shop? This idea of number of images formed by mirrors placed at an angle to one another is used in kaleidoscope to make numerous beautiful patterns. You can also make a kaleidoscope yourself. So now we are going to learn how we can make a kaleidoscope. Okay, so let us see kaleidoscope. To make a kaleidoscope, get 3 rectangular mirror strips, each about 15 centimeter long and 4 centimeter wide. That is, since these are rectangular mirror strips, we can make the length as 15 centimeter and breadth as 4 centimeter. Okay, now look one thing, see only for your knowledge, what is the area of a rectangle? If L and B are the length and breadth of the rectangle, what is the area of that rectangle? Just for your knowledge. L into B will be the area, length into breadth. If so, what is the area of this rectangular mirror strip? It will be 15 into 4, which is equal to 60 centimeter square. Okay, just I asked. Okay, now join them together to form a prism. See, like this. Okay, we are joining each of them in this manner. Now fix this arrangement of mirrors in a circular cardboard tube or tube of thick chart paper. Okay, now make sure that the tube is slightly longer than the mirror strips. Close one end of the tube by cardboard disc having a hole in the center through which we want to see. Look here, make a hole here so that we can see. Now, to make the disc durable, paste a piece of transparent plastic sheet under the cardboard. Okay, like this. Okay, then at the other end, touching the mirrors, fix a circular plain glass plate. Place on this glass plate several small pieces of colored glass, means broken piece of colored bangles. Okay, now close this end of the tube. Now allow enough space for the color pieces to move around. Fine. Now our kaleidoscope is ready. And when you peep through the hole, we will be able to see variety of patterns. Okay, actually, in our school, we have a kaleidoscope. I will show you. Okay, now an interesting feature of a kaleidoscope is that you will never see the same pattern again. Okay, so once you have seen a pattern and then we have made a different arrangement, it's over. Then we look at it, we will see another pattern. Okay, designers of wallpapers and fabrics and artists often use kaleidoscope to get ideas for new patterns. We can see in our dresses there are lot of patterns, and how these patterns are being discovered by using the help of kaleidoscopes. Okay, now again to make our toy attractive, we can wrap the kaleidoscope in a colored paper. That's also possible. Okay, now we have another activity 16.7. Get a plain mirror of a suitable size. Okay, now place it in a bowl. Say like this. See, this is our mirror is placed in the bowl. Fill the bowl with water. Now put this arrangement near a window in such a way that direct sunlight falls on the mirror. We have to place this mirror such a way that this sunlight from this window falls directly on the mirror. Now adjust the position of the bowl so that the reflected light from the mirror falls on a wall. Okay, we have to adjust or change the position of the mirror so that the reflected ray from the mirror falls directly on the wall. Now, if the wall is not white color, fix a sheet of white paper on it. Okay, sometimes the paint on the wall may or may not be white. If it is not white, just make an arrangement of white paper. Fix a white sheet. Now, this reflected light will be seen to have many colors. Okay, how can you explain this? The mirror and water form a prism. Okay, the mirror and the water form a prism. That's how you know that when white light or the direct sunlight passes through a prism, it disperses into its component colors. That is the process we have seen here. As you have seen in class 7, this breaks up the light into its colors. Splitting of light into its colors is known as dispersion of light. And rainbow is a natural phenomenon showing dispersion. Okay, actually this is a small example showing how the natural process of rainbow is happening. Okay, but in case of rainbow, instead of this small bowl, there will be a large pond or something will be there, or even an ocean. Okay, that's the only difference. So that's about now section 16.6. In that, as part of this we have seen that sunlight white or colored. We have conducted this activity, and now we have learned that the sunlight is referred to as white light, but it is composed of 7 colors. Now we have done an activity showing the sunlight has different colors, several colors. Okay, so I think it is clear to you. Now we will stop right here because the next section, that is the section 16.7, what's inside of our eyes, that is a bit more important. So I'm not taking that today because we need to learn that in a better way. Means you should give proper importance to this section. So what all things had we learned today? We have seen regular and diffused reflection, and we have conducted some activity, and we have seen that parallel rays incident on an irregular surface will be reflected in different way, and then rays reflected from irregular surface, we have seen that. Now thus we have derived our definition for diffused or irregular reflection. Now on the other hand, we have seen the regular reflection. Fine. Now another just a fact we have seen, do we all objects due to reflected light? Almost everything we are seeing due to reflected light. For example, moon is there. Now illuminated objects, we can see objects which shine in the light of other objects are called illuminated lights. But sometimes the lights will be emitted from that object itself, such as sun, fire, flame of a candle, or electric lamp. And such kind of objects are known as luminous objects. Now we are asked a question: reflected light can the reflected light be reflected again? Of course, we have seen the example also. Fine, then we have seen periscopes, use of periscopes. Okay, or the underlying principle behind which the periscope working is that the reflected light can be reflected again. Okay, then we have seen multiple images. For that, we have conducted an activity placing two mirrors perpendicular to each other, which are sticked, and the images are formed. Number of images are formed there. Okay, then finally two mirrors are set parallel to each other, and we have seen so many images of the candle placed between them are seen in the mirrors. Okay, now now we have gone for the preparation of kaleidoscope activity. In activity 16.6 we have seen how we can prepare a kaleidoscope. You can do it in our some projects also. Okay, then we have seen the uses of kaleidoscope. Who all are using the kaleidoscope? We have seen that designers of wallpapers, see, designers of wallpapers and fabrics and artists often use kaleidoscopes to get new ideas. Even to make our toy more attractive, we can make the kaleidoscope in a colored paper. Now, in the section 16.6, we have seen sunlight white or colored. In the previous classes, that's in class 7, we have already learned that sunlight is referred to as a white light, but still sunlight is composed of 7 colors. Okay, and we have conducted our activity 16.7 where the sunlight is dispersed into its component colors, and this process is known as dispersion of light. We have used a bowl of water and mirror to make this process happen. And again, this dispersion of light is the underlying principle of a rainbow. Okay, that is also important. Okay, so till this we have seen this, and I want all of you to read the whole chapter till now, because the next section is a little bit important, not it's important. So in order to understand that, you must be thorough with all the previous knowledge. Okay, so all of you go through the lessons, and if you have any doubt, you can ask me. Okay, so thank you.